Here's an example of an application of a hyperbola. You have a comet that's approaching a sun. The sun is at the focus of a hyperbola, and the comet's along the path of the hyperbola. Give you some information here. The comet's on the transverse axis. When it is, it's 400 million miles from the center of the sun. And we know the sun is 600 miles from the center of the hyperbola. Find the equation. Then determine how far away the comet is from the center of the sun when it's directly above the sun on the graph. All right, so we're going to go ahead and draw the picture first. And to make the numbers smaller, let's just have each unit represent a million miles. So here's the picture that we have. There's the hyperbola, and I've got the sun, I've got the comet, and from the information, we know that this length is 400 million miles from the comet to the sun, and the sun is 600 million miles from the center. So we know this point is 600, the center of the sun. And just from the picture, we know that that length has to be 200. So this is just us filling out the picture as much as we can given the information. Okay, so this is a horizontal hyperbola. What we know right away is A, because A is 200, and we know C. C is 600. And as soon as we know what A and C are, we can figure out what B is from this formula here. B squared is C squared minus A squared. So we end up finding out that B squared is 320,000 million miles. All right, so now we need to find the equation of the hyperbola. And given what we have, that's actually quite easy. Since we know A and we know B squared, we can go ahead and just plug in A squared and B squared to the formula, and that is the equation. All right, so the next step is to find out how far away the comet is from the center of the sun when it's directly above. So let's make a little bit of room. All right, so remember, this is the equation we got, and remember, each unit is 1 million miles. Let's redraw this using Desmos. There's an exact picture based on our equation, and what we want is the comet to move right above the sun on the graph. So we want to know what the distance between the center of the sun and that comet is. It looks like it's about 1,600 million, right? It looks like this length from the comet to the sun is 1,600. So let's find out algebraically and make sure. Maybe it's just 1,600, maybe it's a little bit less, maybe it's a little bit more. We need to actually do it algebraically. From the picture, if it's right above the sun, we know x has to be 600, so we're really looking for y. Plug it in to the equation, and what's really nice, at least with these numbers, is that the left-hand term there turns into 9. And when we solve for y, we end up with exactly 1,600 million miles as we thought. So the graph and the algebraic answer match each other. And that's the answer to the last question.